Imagine looking up into the night sky and seeing a sight so magnificent that it rivals the brightness of the sun and turns night into day. This is not science fiction, but a possible reality that astronomers are eagerly awaiting. Betelgeuse, a red supergiant star some 600 light-years away, may be on the verge of a supernova explosion. Such an event would be once in a lifetime, visible to the naked eye and a profound moment in the history of astronomy. Astrophysicists and astronomers all over the world are eagerly waiting. This excitement stems from Betelgeuse's recent behavior, which shows signs that its lifespan may be coming to an end. The star's unusual dimming events and surface activity have fueled speculation of an imminent supernova. If Betelgeuse were to explode, the light would be so bright that it could be seen during the day, making it appear as if we had a second sun. Astrophysicist Brian Cox explains, when Betelgeuse explodes, it shines brighter than the entire galaxy for a few moments, and even weeks later we see the remnants of a supernova. The thought of a star exploding so brightly that it could rival the sun is not only exciting, but also humbling, reminding us of the vast and unpredictable forces of our universe. Betelgeuse, a star in the constellation Orion, has been a target of intrigue and research for astronomers for centuries. Its great size and brightness make it one of the most visible stars in the night sky. But recent developments have brought Betelgeuse into the spotlight of astronomical research. In late 2019 and early 2020, Betelgeuse experienced a dramatic decrease in brightness, an event now known as the Great Dimension. This sudden change led many to speculate that the star was about to explode. Betelgeuse, a red supergiant star, has shown signs of instability and will see a dramatic decrease in brightness in 2019 and 2020, known as the Great Dim event. These fluctuations fueled speculation that the star was about to explode. At first, scientists thought the dimming signaled the star's last efforts, but it was later attributed to massive dust obscuring some of the star's light. Betelgeuse is a massive star about 1,000 times the size of our Sun and is in the final stages of its life cycle. In its core, nuclear fusion takes place, which turns helium into heavier elements such as carbon and oxygen. This process releases enormous amounts of energy, causing the star to expand and contract in cycles. These cycles can cause dramatic changes in brightness as seen from Earth. In addition to these natural cycles, Betelgeuse's instability is also due to its size and age. As a red supergiant, Betelgeuse's lifetime is very short compared to smaller stars like our Sun. Our Sun has an estimated lifetime of about 10 billion years, but Betelgeuse is estimated to be only a few million years old. This is because larger stars burn through their nuclear fuel much faster. When Betelgeuse runs out of fuel, it can no longer support gravity, causing a catastrophic collapse and explosion. The darkening of Betelgeuse was caused by the interaction of the dust cloud and the cooling of the place where the material was lost. Betelgeuse, which is 1,000 times the size of our Sun, ejected a significant amount of material that caused these observable changes. In March 2024, the American Association of Variable Star Observers reported another decrease in Betelgeuse's brightness, prompting more excitement and research. 2019-2020 The Great Dimming event of 2011 was particularly exciting for astronomers. Initially, there was widespread speculation that the dimming signaled the imminent explosion of the star. However, further observations showed that the decrease was caused by massive dust ejected from the surface of the star. This dust cloud blocked some of Betelgeuse's light, making it dimmer from Earth. It is assumed that the cause of the dust explosion is related to the convective currents of the star. Betelgeuse, like all stars, has convection currents that transport energy from its core to the surface. These currents can create large swirling bubbles on the surface of the star. When these bubbles burst, they can push material into space. In the case of Betelgeuse, that ejected material formed a dust cloud that temporarily blocked some of the star's light. Another factor influencing Betelgeuse's decline is its erratic surface activity. Betelgeuse has massive convective cells on its surface that can create hot and cool spots. These temperature fluctuations can cause changes in the brightness of the star. During the Great Fading, Betelgeuse experienced both dust ejection and cooling, which together caused a significant decrease in brightness as seen from Earth. despite extensive research, the exact location of Betelgeuse remains elusive. Its turbulent surface activity can create optical illusions, making it difficult to judge whether the star is nearing its end. Some theories suggest that Betelgeuse may be the result of a merger between two smaller stars, which would explain its unusual properties and rapid rotation. Betelgeuse's rapid rotation is particularly unusual for a red supergiant. Most red supergiants rotate slowly, but Betelgeuse rotates much faster than expected. One theory to explain this is that Betelgeuse is the result of a binary star system merger. In this scenario, two smaller stars merged to form the larger Betelgeuse. That merger would have transferred angular momentum to the newly formed star, causing it to spin faster. This theory is supported by observations of the chemical composition of Betelgeuse. Betelgeuse has more nitrogen in its atmosphere than typical red supergiants. This is explained by the merger of two stars that would have mixed in their cores and brought nitrogen-rich material to the surface. However, the binary star merger theory is not universally accepted. Some astronomers believe that Betelgeuse's rapid rotation may be due to its surface activity. Eddy convection cells on Betelgeuse's surface can create optical illusions that make the star spin faster than it actually is. Betelgeuse has fascinated people for millennia. Ancient civilizations such as Egypt and Mesopotamia revered the star for its brightness and size. The systematic study of Betelgeuse began in the 16th and 17th centuries with advances in telescope technology and continued into the 20th century with the development of spectroscopy and astrophotography. The earliest records of Betelgeuse come from ancient Egypt and Mesopotamia, where the star was revered for its brightness and striking red color. In those ancient cultures, Betelgeuse was often associated with the gods and believed to have a special meaning. For example, in ancient Egypt, the god Betelgeuse was associated with Osiris, the god of the afterlife. In the Middle Ages, astronomers such as Ptolemy mentioned Betelgeuse, who described the star as visible and reddish. The observations of Ptolemy of Betelgeuse were recorded in his star catalogue Almagest, one of the most influential works in the history of astronomy. Systematic study of Betelgeuse began in the 16th and 17th centuries, when telescopes became much more sophisticated. Galileo Galilei, one of the pioneers of modern astronomy, observed Betelgeuse and studied its brightness variations in detail. Galileo's observations laid the foundation for future studies of variable stars. In the 18th and 19th centuries, astronomers such as William Herschel and John Flamsteed made important contributions to the understanding of Betelgeuse. In particular, Herschel helped classify Betelgeuse as a variable star by observing changes in its brightness over time. A decisive breakthrough in the understanding of Betelgeuse occurred in the 20th century with the development of spectroscopy. Thanks to this technique, astronomers were able to analyze the chemical composition and temperature of distant stars for the first time. Spectroscopic studies of Betelgeuse showed that it was a red supergiant in the final stages of its evolution. Modern technology such as the Hubble Space Telescope and interferometry have changed our understanding of Betelgeuse. High-resolution spectroscopy and computer simulations now allow astronomers to observe the state and evolution of a star with unprecedented precision. Observations in 2024 revealed another major dimming, strengthening the theory that Betelgeuse is approaching a supernova explosion. The Hubble Space Telescope, launched in 1990, helped study Betelgeuse. The high-resolution imaging capabilities of the telescope allowed astronomers to observe the surface of the star in unprecedented detail. These observations showed that there are large convection cells on the surface of Betelgeuse that create hot and cool spots that cause brightness fluctuations. Interferometry, a technique that combines light from several telescopes into a single high-resolution image, was also crucial to the study of Betelgeuse. The interferometer-equipped VLT, Very Large Telescope, in Chile provided detailed images of the surface of Betelgeuse. These images revealed the complex and turbulent nature of the star's surface activity. High-resolution spectroscopy allowed astronomers to analyze the chemical composition and temperature of Betelgeuse's atmosphere. These studies provided insight into the evolutionary state of the star and its imminent supernova explosion. Spectroscopic observations have shown that Betelgeuse's atmosphere has a high concentration of nitrogen, consistent with the binary fusion theory. computer simulations also played a crucial role in predicting the future of Betelgeuse. These simulations use observational data to model the internal structure and evolution of the star. By comparing these models with observations, astronomers can predict when Betelgeuse will explode as a supernova. Current models suggest that Betelgeuse could explode within a few 100,000 years, although the exact timing is impossible to determine. The explosion of Betelgeuse as a supernova has significant implications for our understanding of stellar evolution and stellar life cycles. Supernovae are the most energetic events in the universe, releasing more energy in a few seconds than our Sun does in its entire lifetime. The study of the Betelgeuse supernova provides valuable information about the mechanisms that drive these explosive events. The Betelgeuse explosion also affects our understanding of the interstellar medium. When a star explodes as a supernova, it throws a significant amount of material into space. This material enriches the interstellar medium with the heavy elements necessary for the formation of new stars and planets. By studying the remnants of the Betelgeuse supernova, astronomers can learn more about the processes that shape the evolution of galaxies. Understanding Betelgeuse's supernova journey sheds light on the nature of these cosmic events. Historical records of supernovae, such as those observed in AD 185, AD 1054, and AD 1604, show their importance in shaping our understanding of the universe. The development of astronomical tools and techniques over the centuries has allowed us to discover the secrets of dying stars. The oldest recorded supernova in human history occurred in 185 AD. The event was recorded by Chinese astronomers who described a guest star appearing in the night sky that was visible for several months. Modern astronomers have identified this event as a Type II supernova, the same type of supernova that Betelgeuse is expected to produce. The supernova of 1054 AD, known as the Crab supernova, is one of the best documented events in the history of astronomy. Chinese and Arab astronomers recorded the appearance of a new star in the Taurus constellation, which was visible even during the day for several weeks. The remnants of this supernova, known as the Crab Nebula, are still visible and have been widely studied by modern astronomers. In 1604, a supernova known as a Kepler supernova was discovered by the German astronomer Johannes Kepler. This event was visible to the naked eye and was one of the last supernovae observed in our galaxy. Kepler's detailed observations of the supernova and its remnants provided valuable information about the nature of these explosive events. The development of astronomical tools and techniques over the centuries has allowed us to discover the secrets of dying stars. In the 20th century, the development of radio astronomy and space telescopes changed our understanding of the supernova. These tools allowed astronomers to observe supernovae in distant galaxies and study their remnants in detail. Radio telescopes have been particularly useful for studying supernova remnants. These telescopes can detect the radio waves emitted by supernova shock waves as they travel through space. By studying these radio waves, astronomers can learn more about the energy and dynamics of supernova explosions. Space telescopes such as the Hubble Space Telescope and the Chandra X-ray Observatory have taken detailed images of the supernova remnant. These telescopes can observe the high-energy radiation emitted by supernova remnants, providing insight into the processes that cause these explosions. Supernovae play a crucial role in the evolution of galaxies and the formation of new stars and planets. When a star explodes as a supernova, it throws a significant amount of material into space. This material enriches the interstellar medium with the heavy elements necessary for the formation of new stars and planets. Heavy elements produced by supernovae, such as iron and silicon, are the building blocks of planets and life. Without the enrichment of the interstellar medium by supernovae, the universe would be a much less hospitable place for life as we know it. Supernovae also play an important role in the dynamics of galaxies. The energy released by supernovae can fuel the formation of new stars by compressing the gas and dust in the interstellar medium. This process, called triggered star formation, can create new generations of stars and planets. Waiting for a possible Betelgeuse explosion highlights the ever-evolving nature of astronomy. Each new observation and discovery brings us closer to understanding the life cycle of stars and the dynamic changes in our universe. If we continue to observe Betelgeuse, seeing a supernova in our lifetime is an exciting possibility. The study of Betelgeuse and other supernovae continues to advance our understanding of the universe and our place in it. Each new observation and discovery brings us closer to unlocking the secrets of the cosmos and understanding the fundamental processes that shape the evolution of stars and galaxies. As we await the inevitable explosion of Betelgeuse, we are reminded of the ever-evolving nature of astronomy and the dynamic changes occurring in our universe. The possibility of seeing a supernova in our lifetime is an exciting prospect that underscores the importance of continued observation and research. The Betelgeuse supernova prediction is a reminder of the immense and unpredictable forces in our universe. It is a humbling reminder of our place in the cosmos and the ongoing quest to understand the fundamental processes that shape the evolution of stars and galaxies.